All right, so now we have our contract pretty much written. One of the things that we still haven't done though is we haven't provided an option for us to remove the funds out of the contract. So people will send funds to the contract. Now we got to get the funds back out. And it's actually very simple. All we need to do is realize that when Neo is trying to do a withdrawal from a contract, it's always going to run the verification script to see if that withdrawal will pass or succeed. So if runtime check witness owner return true. Now the owner can withdraw the funds out of the contract and could technically contribute whenever they wanted to. Why would they do that though? But yeah, there we go. All done. Video over. Just kidding. No, what we've done is we've written a whole lot of code and we haven't tested anything here. And so what I'm going to do is pop open the debugger. I want to reset my chain here. Oops. I want to reset my chain. Maybe rebuild. Or is that, oh, that rebuilds the code. I didn't want to do that. Oh, blockchain reset. Let's just make sure storage. Okay, wow. Now I'm stuck in some sort of infinite loop here. I'm going to go back to Visual Studio here, rebuild this. And you'll notice also that I did a rebuild. If I haven't mentioned this before, Visual Studio is very smart. It realizes if the code hasn't changed and you just do a build, that it won't recompile the DLL, which won't re-trigger the Neo debugger, which converts that DLL to the Neo bytecode. So if you do a rebuild, it will then always recompile the DLL and always regenerate the Neo VM. So just a little tripping point you may run into. So let's see if I get out of this loop here. So you can actually edit this code in here and do a build. It didn't seem to really work very well for me for whatever reason. I tend to use just Visual Studio and swap back and forth between them. Okay, so one of the things that's very handy for this kind of testing here is there's this key tool, and you can just generate a random private key. You can hit decode and you can get all the information about that key. So the address, the script hash, so this would be the hex encoded script hash. You could see it in bytes. So if you look at some C# smart contract examples, a lot of times you'll see a byte array hard coded in the header for the owner. So that's this is one way to get that. You could put your own private key in there and just decode it. What the public key is, and then the private key in its various different formats as well. So a byte format as a WIF, if you've ever used that to open a wallet via your WIF, that's just your private key, this byte array basically encoded in a way that's simpler to work with. That's all it is. So, you know, it's still a private key, keep it secure. All the keys I'm going to use in this demo are not public keys. I've generated them all. So you can try and use that data, but it won't get you anywhere. So one of the things that I usually do is I have a little spreadsheet I build when I'm doing my testing here. So I've got my KYC administrator, the address, the private key, and its script hash here. Sometimes I've got that as hex encoded depending on the tool I'm using. For this example though, I want to do a few things here. So I want to run the initialize method here. Actually, let's run it here. I'm going to put that key in there and click load private key. I'm going to double check that address there is AGE6. Okay, so this shouldn't work. I should keep specifying thing here. The check witness is set to default. That means it's actually going to check the witness here. So if I run this, it should return false because I'm running now as the KYC administrator. The initialize is only going to accept things from the owner, I believe. Checking witness, script hash, return false. Okay, so that is what we want to happen. For the sake of convenience, we can say always return true if we don't want to keep loading and unloading and loading and unloading keys here. So I'm just going to run our initialize method, which also failed. Oh, you know why, I bet. One of the annoying things with this is it always remembers this asset transfer and it doesn't remember when you reset it back. Maybe I got to set it to 0 and set it to none. This is something we're going to go over right away here, but. And if we look at storage, it is initialized. Okay, so now, see, it's back to 10. Very annoying. Little bug in that right now. We're going to run a check witness as the default. We've got that key loaded. I want to do a KYC register, and I'm going to pull up the bytes for this KYC user and just pass that in. And if I look at storage, I should see that there's a KYC edition now, KYC underscore this amount, or sorry, this address with the value of 1, so it exists. Now, what I want to do is I'm going to step through a check here. So I'm going to run this as this KYC user. So let's load up that key. I'm going to send in one neo, and I'm going to do this as a verification script. So that's how we can explicitly run our triggers here. So here it's going to say if we're the owner, we are not. Now it's going to say can sender contribute. We're going to step in, is the sale open? Which actually it's not, because we haven't opened it yet. Let's do that here. Start sale, 1, 1, 0, 0, 0, 0. So I'm going to make this run for basically every block ever. We don't need to transfer anything in. We're just going to return true so that we get past all our verification as an application trigger. Run that. Crack open storage, see 1 and a big number. Okay, back to this now. KYC register. What was I was doing the verification script. So we've got one neo we're passing in as this user with these options of verification. And sorry, I just want to do this as a step through because we're going to run into an issue that I just want to show you here. So one neo as a verification trigger. Check witness can be whatever because we don't care in our verification trigger. Okay, is the sale open? Now we're into our KYC. Is KYC verified? And we're going to look at this get sender. So it's going to look at the asset. So there should be one of the neo asset ID. And this is where you can't hover over sender, as I've mentioned, to see what the value of it is, but you can actually look on the stack here. And you'll see that the stack is this ACB, which is not one of our addresses here. This is something I've banged my head against forever, and I still don't have an answer, is that it may just be that the way that Neo Debugger is figuring out who the sender is kind of arbitrary, and it's not including the key that's loaded or something like that. So at this point, it's always going to return false. And this is where it comes down to maybe either I don't know how to use this tool properly, which is more than likely, or this tool is doing, has some limitations of it. And this is where we have to start testing things on the actual blockchain or on a private net, or using, different tools. So I've not gotten this to work. So it says a KYC failure, and we exit. So, kind of disappointing, kind of annoying. If someone has a solution on how to get around that, that would be great. If we really want to just kind of see the behavior, I would just comment out this code here so that we're not doing our KYC check. But you got to make sure you enable that when you go and release this to production. So it's always very good to review your code for any removed sections that you may use for the debugger. That's where I kind of don't like it. You know what? But let's just comment this out and build it. And we'll run it through. And back to the debugger, contract, run. So that's who we are. We're going to run a verification trigger, mint tokens, and we've set our amount here of 1 neo. Of course, I did not run this as a debug, so we could actually walk through it here. Just make sure we are sending neo. So we know that isSaleOpen will return true. We're going to check how much neo was sent to the contract and how much gas was sent to the contract. So again, you'll see here in the stack that neo was set to 1 with 8 zeros after it. 1, 2, 3, 4, 1, 2, 3, 4. Yeah, 8. Again, that's a number of decimal places, just neo's working in whole numbers. So if the neo contribute value equals 0 and gas contribute value equals 0, this is a withdrawal attempt, which it's not. And so here we've detected that that the sale is open. They would be KYC'd if we didn't have that code commented out, and they have sent neo or gas. And so we return true, which just basically tells the code that it's valid to send through the actual application invocation. So now we've got mint tokens. We're sending 1 neo. Check witness shouldn't matter, but we're going to run this as an application trigger now because we've already done the verification. We're going to do this fund transfer check, which just runs through basically the same stuff we just stepped through. So I'm going to try and rapidly go through that. And then we should get to our mint tokens method, which actually kind of runs a lot of the same code again. So there may be an opportunity to refactor a little bit of this because it is checking again if the person has sent funds to the contract. Okay, so we should see here who this person is, which again is a different address. So I wonder if this kind of get sender is just returning a random address every time this contract's run, just a limitation of the debugger. So we're saying new contribute value times big integer 1, which has failed. I wonder if I can figure out I can't resize this, can I? Why would I want to do that? So it looks like there's probably this is our neo contribute value on the stack times a big integer 0.01. So this is probably something with the VM not liking it here. So what I'm going to do is I'm going to pause the video. I'm going to figure this out because you don't want to sit here. We're already 15 minutes in, sit here watching me do it. So be right back. Okay, so I got that figured out here, and there were a few things going on. So one of the things was this Neo contribute value was returning a ulong here, and I was trying to multiply that by a big integer. So I'm thinking it was kind of having a casting issue. So I actually just expanded out this neo contribute value and put in the swap rate here as a ulong. So one of the things I found really annoying debugging this was that every time I had to step through, I had to step through so much code of it checking the sender and is the sale open and all that. I don't care. So what I did instead is I put in some runtime notify lines here to give me some output. And I can just pop that over here. And so you can see here, I just got my output. I just ran it. I didn't do the step. I just did a run. Actually, I'll just do it right now. Boom. There's my output of what happened. Right? So they contributed 1 neo. They contributed no gas. I have this calculation line. Let's maybe just bring that up here if I can find it quickly. Transfer balance of, must have gone past it here. Yeah, so here's my calculation line. So the first parameter is 2, so that's the swap rate. And then I had neo contribute value divided by swap rate now. Now, before we were multiplying by a fraction, me forgetting that neo does not like decimal numbers. It wants to deal in whole numbers. So when I had a swap rate set of 0.01 or 0.1 or whatever it was before, is that this calculation line said calculation slash null slash I can't remember what the last number was, maybe a null here. So it does not know how to deal with this number here. So I just changed this to be a little bit simpler. So basically we're giving you 50% of your neo by dividing it by 2. And then we see here that the new tokens generated. So you sent in 1 token here. So we're actually giving you half of that. So there will be 1 less 0 here. And then the new tokens, here will be that. So the new tokens is done by taking, and then I multiply it here. So hey, look, more bugs. There. So I'm basically just copying this into here. I could extract this out to a variable if I want, but I will remove these runtime notifies. They're going to cost you a little bit in gas to run them, but it's also giving out information as well. So if I were to be an attacker and trying to figure out how your code works, if I were to look at all the notifications that come out, I could see, oh, well, in this situation with these inputs, it ran to this line. And if with these inputs it got to here, and with these inputs it got to here, so I can get a little feedback if my attack is working or not. So I intentionally remove these typically, except for when I want information to be broadcast out of here. But for debugging, kind of handy. So that's why that worked, and that's kind of a quicker way to debug some stuff here. So I'm going to have a similar issue with this, obviously, here. And I'm going to say, I'll just divide that by 5 in this case here. You can do whatever math you want in this area, but that's how I wanted to tackle that. And then I made sure that the transfer method was run there. So sorry for the length of this video. I know in the first few minutes I said we were done, and now we're 20 minutes in, but I wanted to show you some of the tricks here of debugging this kind of stuff, and just some of the headaches you can run into with these kind of things. I really thought this was a casting issue, and then it turned out to be that it's because I was using a decimal number, and the compiler doesn't complain about it ever, but when you actually run it, it does. So you do run into a lot of the stuff with Neo, I found, where you expect it to behave as one type and it doesn't, and maybe that just, especially as a C# program, you expect it to work. It's valid C# code, but when it gets to the VM, it doesn't. So anyways, that's all I want to talk about. That pretty much concludes us building our ICO, a lot of the things to it. I know it's not fully fleshed out, but that's an exercise for you because there's so many different ways to do it. And the next thing to do is to test this on a private chain using there's a variety of tools to do that before you go, and then test that on testnet and then deploy that to production. So thanks everyone.